Welcome to Friday. It's the last day of the first week of your 6 weeks of research methods. Today, we're going to get into the fun stuff. I don't know, it's all kind of fun for me. But we're going to talk about research designs, various types of research designs. In other words, how do you create your study? This stuff is really fun. So I'm just going to mention the highlights that you should have picked up on yesterday in chapter 1. There wasn't enough here to actually make a whole video, so I thought you'll read it, and I'm just going to hit the highlights. Basically, you read about psychology and science, and the thing to pick up from there is that psychologists use the scientific method, and psychologists make data-driven decisions and look to use data in all that they do. So it's very data-based, science-based discipline, psychology is. There are two kinds of overall research, basic research and applied research. So it's good to know the differences or what each one is. Basic research versus applied research, that's in your book. Get a sense of how those two things differ. At the end of every chapter, there is a research study and then there's a summary. And both of those things can be very helpful in terms of you understanding what the chapter was about and getting to apply your knowledge. And if you remember, applying knowledge is one of those parts of Bloom's taxonomy, one of those ways in which you have higher order thinking. Applying knowledge helps you really learn things much, much better than simply memorizing and regurgitating. And so I would encourage you to take a few minutes at the end of each chapter and read through those research studies that demonstrate various principles from the chapter, and then read through the chapter summary. Just make sure that you can answer those questions, that they make sense to you. This way, you will learn things so much more easily that doing the activities and doing the research proposal and the final smackdown and the quizzes, that'll be much easier for you. All right, so that's chapter 1. We use the empirical method. So that means psychologists use the scientific method. This is a kind of epistemology. Epistemology is essentially the study of how people know things or how people say they know things, what kinds of ways things they rely on to know something. And so authoritarianism, for example, is you know something because an authority said it. And so you would say, oh, well, I know this is true. Why do you know? Oh, because Dr. So-and-so said it. And so he said true things. And so you're basically saying the reason you know something true is because somebody with authority said it. Or it might be that it's rational, it makes sense. It's just very compelling and logical. Well, how could you not believe this? It's just logical. This is just how it is. So those are ways of knowing things. All in all, at the end of the day, the person who's responsible for evaluating truth claims is you. You're the one. You can't ask someone else to do it for you because then that's authoritarianism and you're letting them be the authority. And so, or, maybe it's your friend Ted, and it's like, if Ted said so, then it's true. And then it's Ted's responsibility. But, we all know when it comes down to the bottom line, you're the one who is the person who's responsible for determining what is true for you. So how does research answer questions? So research is the empirical method. Basically, you're saying it's true if I can observe it. If I have data that supports it, then I know it's true. And so researchers use the empirical method, psychologists use the empirical method. Science is basically the empirical method. And so in science, we have to look at what does that mean? How does research answer questions so that we can eventually figure out truth? Well, that's like the ideal. And the more we learn, really the more we realize we don't know as much as we need to know to answer those questions. And so you have to kind of balance this idea that we've found truth with, and we've also found out that there's a lot we didn't know. And so don't get stuck in this idea that just because you found something that you're correct. For example, in 1997, was when scientists found out that brain cells can actually be new. You can grow new brain cells. Before that, they really thought you couldn't grow new brain cells. And so when I was growing up, there were lots of ads on TV that would say things like, if you use drugs, then that's it. You've killed your brain cells and you're done. There's no way you can get over that. You know, once they're dead, they're dead. You never get more. That was a common knowledge. It was totally accepted. Once you kill your brain cells, then they're gone forever and you can never make more. Well, then in 1997, they're like, well, guess what? You can make more brain cells. Hello. And so people had to eat a little bit of crow. So that's why I think it's important to be careful. It's important to be careful, be cautious in terms of believing that you know all of the things. It's easy for scientists to say they know all the things, they've done the studies, they can tell you for sure this is what it is, and then all of a sudden this brand new thing happens. Another example, in 2015, that is when scientists first realized that the lymph system, which is a circulatory system in your body connected to your blood vessels, you have blood, and then when it gets to the place where the vessels are so small, red blood cells can't even fit in there, then what you have left is lymph fluid, and that lymph fluid is collected throughout the body and then fed back into the blood system, and you actually have more lymph fluid than you do blood. They're all connected, but so people were saying, well, the brain is separate. There's no lymph flow into the brain. It's totally separate because you've got this blood-brain barrier, and we don't see any way for the lymph to flow into the brain. And so it's just weird that people are having these brain problems that seem related to lymph, because it's impossible that there's any lymph there because we've watched it, we've looked at it, we've done science. And then in 2015, they're like, well, we're wrong. Guess what? The brain does connect to the lymph system. It sort of has its own little version also called, well, they called it the glymph system, which is an endless source of entertainment for me because I just think people walking around saying glymph, I don't know, I find entertainment pretty much everywhere, and that's one of the places for me, the glymph system. Yeah, okay. So you can't be positive that you know all of the things. All we can do is collect evidence. So let's talk about what some of those words are that have to do with the scientific method and experiments. So what is a variable? A variable is something that varies. Anything that varies is a variable. So amount of sleep that you get every night, that is a variable. How happy you are, how many eggs you eat for breakfast, whether or not you eat eggs for breakfast, how far you can run, how many times you breathe in a minute. There are all kinds of variables, okay? Those are variables. Observations are how many things actually, let's not put it that way. An observation is what you see. If you can observe something, then you've created an observation. And so let's say you're watching a kid. When I was in college as an undergraduate, one of the things that we did in one of my classes was we went to the child care center. This was at Brigham Young. We went to the child care center, and you could sit behind the glass, the window, like there were mirrors, so they couldn't see you watching, but you could sit there and just watch the kids, and you would observe them, and you would make observations. And so you could say, I have an observation of every time this kid threw a block. And so I observed him throwing a block 5 times. Those were 5 observations of block throwing, essentially. So you're watching, you're looking, you're writing down what you've seen. Those are observations. Subjective data versus objective data. So subjective data would be data that you are interpreting as you write it down. You might say, oh, well, I observed this child and he was very angry. Well, you're guessing that the child's angry based on how you interpret the child's behavior. Whether or not the child's angry, you don't know, but you think that they are, and that's a subjective interpretation. So that's subjective data. Objective data would be data that is not subject to your interpretation. It's data that you have. So if you count the number of red cars that drive down your street, that's objective data. We had, 27 red cars. Assuming you know how to, assess the color red, we're just going to make that assumption that you're correct with red. And then you count how many cars that drive down. You could be counting blue cars if you want. You can groan. Okay. Levels of a variable. This would be something along the lines of having low level, medium level, high level. You could say a level would be 5 times a day, 12 times a day, 72 times a day. Those could all be different levels of a variable. And so a variable, not all variables are levels, but some variables are something that you could do a level with. You have to be able to have more or less of it. And so if it's once a day or not, then you only have the level of present or absent. If you have a lot of it, a little of it, it just depends on what kind of variable it is. Some variables are continuous. And so what that means is, like, for example, amount of time you sleep, that's a continuous variable. It's not yes or no, it's how long did you sleep? And you could measure it continuously. In other words, your measure has a 0 and it has a number scale that goes from that 0 all the way up to whatever the maximum that you could sleep per day, which would, I guess, be 24 hours. And so you would measure this continuous data. Probably you would guess minutes. If you wanted to measure somebody's sleep, you would probably measure it in minutes. Categorical data would be like all or nothing. I sleep or I don't sleep. I eat ice cream or I don't eat ice cream. It's not how much ice cream. That's a continuous variable. It's yes or no. So that's categorical data. You look at an observational study, and what you're doing is you're just looking. You're not making any changes to what's going on. You're just observing. And so observational studies are studies that just look at something. You're not changing any variables. So when we talk about manipulating a variable, what we're talking about is changing something that's going on in the experiment so that some people get one thing and the other people get the other thing. That's a manipulated variable. In other words, the researcher, the person who's doing the study, is manipulating the variable. It's changing the variable from one group to another. So an observational study won't ever have a manipulated variable because all you're doing is observing. Now, if you do manipulate the variable, it's no longer an observational study. What you're doing is something more like an experiment because you are changing the variable from one group to another. So those are some basic vocabulary ideas. Probably you all are familiar with most of those things, probably all of them. Just reviewing them to make sure that we're all on the same page. So let's talk about research designs now. There are 3 basic kinds of designs. So we'll talk about more specific kinds in a second, but we'll first really get a grasp on these 3 basic kinds of designs: frequency, association designs, and causal designs. So when you do a frequency design, you're basically doing descriptive observational kinds of work, where you're just collecting data to find out about something. You're just describing the group. And so let's say you're looking at a group of college students and you want to know what is their rate of depression. Well, that's a frequency design. You are trying to find out what is the frequency of depression in this population or in this sample or in this group, whatever it is. People's drug use in the summer versus the winter. That again is a frequency design. You're trying to figure out what does this look like in the summer and what does it look like in the winter, so that you have an observation that describes the drug use frequency. Or what kind of training do people's therapy dogs have? Again, observations, you're looking at just collecting information about. You're not changing anything in the study. Association is a study that looks at the relationship between 2 variables. So an association study could also be drug use in the summer versus the winter, where you're looking at, does the season make a difference in terms of people's drug use? Okay, are those variables related? Does one change when the other changes? Essentially, that's what it is. Now, if one changes and the other doesn't change, or doesn't seem like there's any relationship, doesn't mean that it's not an association study. It just means that the results are that no, the variables are not related. We did the study to see if it's related, so we did an association study. Turns out they're not related. We still did the association study. It's just that there was no association. Make sense? All right, so you're looking at, are variables related to each other? So confidence in women. Do men prefer confident women compared to other kinds of women who are maybe easy to control? You're looking at the association between men's preferences and whether a woman's confident or not confident. What about predicting the amount of vegetables you eat based on what state you live in? So that's an association study again, all right? A causal study. Causal study, you can identify in a causal study if one variable makes another variable happen. Now, you gotta be really cautious with causal studies. We'll talk about this in a second, because it is awfully hard to control all of the things. It seems that particularly with humans, there's something else that's out there that might also affect the variable you're looking at. So you can't really say for sure. Most of the time, you can't say for sure that something actually caused another thing. But we create causal designs, a lot, because we want to see if one variable makes another variable happen. So for example, does poor sleep cause depression? The science on this actually says yes. They're bold enough to use the causal word because they've collected so much data in so many ways that they're pretty clear that poor sleep can cause depression. So that is true, and something that you should probably look into for yourself. If you want to protect yourself from becoming depressed, certainly make sure that you get enough sleep. So here are some examples. Now, last couple, whenever it was, this week, we talked about well-being therapy in our example. Well-being therapy in medical school freshmen. So that was an association study. It's describing, but it's also looking at the connection between the two. If we give you well-being therapy, will that help you? We said, yes, it will. So you'd like it to be causal. Well-being therapy causes you to have more adaptation and less distress. But we can't say it causes it, because there are other explanations that we can't fully control. So we can't say there's a strong association. And that's probably good enough for most people. It's good enough for me in many ways. If there's an association between having well-being therapy and then feeling better, then I would recommend well-being therapy. From your book on page 13, here are a couple examples. One of the studies they talked about was writing to-do lists, and said that writing to-do lists helps people fall asleep faster than writing down a list of their completed tasks that they did for that day. And so good to know, but also that's another study of association. Writing to-do lists is associated with falling asleep faster. They talked about specific warnings working better in terms of memory accuracy than general warnings. And so if you want to increase memory accuracy, then there's an association between being more specific. Hands-free phones. They interfere with your driving more than just listening to music interferes with your driving. So we think, well, you have hands-free and you're just listening, but it does seem to be associated with more problems in driving and more distraction than music does. So that again is a association study. Why do we not use the word causal? Human lives are very complex and you have to control all of the things. When you're looking at an experiment, you want the only thing to vary to be the variable that you want to change, the manipulated variable. You want everything else to be the same so that you can say everything was the same. The only thing that changed was the manipulated variable. Therefore, the manipulated variable is what is responsible for the change. That is the ideal. So the change in the experimental group resulted from the manipulated variable, not from anything else, because it was controlled for in both groups. In other words, The control group had all the same things except for that one, the manipulated variable. And so you can set up a study, and you can even have very well controlled studies, very well designed studies. There's still really only evidence of an association, because it is really difficult to say that you have controlled all of the things, or that you know enough to have controlled all of the things. Like, for example, let's say that, now this is crazy, okay? So don't think this is true. But let's say there are radar beams that come at you from space. And so you develop this study design, and you're looking at the effect of eating broccoli on sleep. And everything is perfect. You have it in exactly, just really tightly controlled. You have made clones, let's say. You've made clones of everyone. And so everyone is exactly the same. The only thing that's different is that one of them are eating broccoli and the other group is not. But let's say you have these radar beams that come from outer space, and they make changes. You don't know that in your study. And let's say the sleep is a result of the radar beams from space instead of the broccoli. Well, you wouldn't know that, because you don't believe in radar beams from space coming and interfering with people's sleep. And so you would say, look, the broccoli made the difference. Broccoli causes the sleep issue. When in actuality, it was the radar beams from space, but you don't know about that, so why would you have controlled for that? Really stupid, weird example, but I'm hoping that it helps you understand why, even in well-controlled design studies, you can really be clear that it's an association. It's awfully hard to say the C word, the causal word. What you end up doing is collecting a lot of studies. And if a lot of studies seem to say the same thing, then what you have is the weight of the evidence. You could say the weight of the evidence is in favor of this idea that broccoli is related to sleep, or that broccoli causes better or worse sleep, or whatever it is. I just kind of made that up. So replicating the experiment means you're doing it over and over again. If you replicate it and you keep getting the same results, then it does seem more likely that the results that you found are accurate. Then you have the weight of the evidence, but you may not be able to yet to say that you are 100% sure that it is causal. A lot of people use causality at that point, and it's justifiable. I get it. It is, if you're just going to be really, really nitpicky, it is much easier to say, yeah, most of these studies are really association studies. Okay, so let's get a little more specific. We've got our frequency, association, and causal studies. If you look at the specific kinds of frequency, association, and causal studies, this is what you see. Case studies. A case study is where you just look at one person. Or let's say there's a woman in the hospital, and she had a really weird thing happening with her liver panel. So they give her a liver panel, and it's just weird. And so the doctor says, wow, this is weird. I'm going to write this up. I'm going to submit this to a journal, and they'll publish my case study. And so the case study is just about one person. So N equals 1. N equals the number of people involved in the study. So N equals 1. Or the number of observations. N might be number of observations, etc. And so a case study, you're not able to really manipulate a variable much. You're just observing. And so you're looking at the frequency, or describing the descriptive study of one person, if that makes sense. Doing a survey. Generally, a survey is a frequency study unless you're trying to correlate one variable with another variable, in which case that's an association study. So if you do a survey on how many people are depressed or how many people love eating broccoli, either one of those are descriptive observations, frequency studies in a group, a sample, a population, all right? If you're looking at the relationship between one variable and another, so let's look at the relationship of people who love trees and people who eat hot dogs. That's a relationship. Are these two variables related? Then that's a correlational kind of study, an association study. And so you can correlate two continuous variables. So that would be, let's say, amount of sleep, because we just talked about that. And then let's say we have a variable called love of broccoli. And so you can measure that on a scale of 0 to 100. how much do you love broccoli? So that's a continuous scale. Somebody who loves broccoli at a 97 loves it way more than a person who loves it at a 12. Okay, so those are both continuous variables, amount of sleep and love of broccoli. Now, you could look at how those are related, and you have an association study. You're correlating the two. You could also look at the association or a correlation of two categorical variables. And so you could say the categories are, what day were you born? Was it Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday? So those are categories, day of birth. And then you could look at, do you like ice cream or not? And the answer is yes or no. It's not how much, it's just yes or no. And so then you can look, is there an association between the day that people are born and whether or not they like ice cream? Those are two categorical variables. And then you would do a different statistics, but it would still be a correlation between those. Is there any correlation between day of birth and love of ice cream? Yes or no? Okay. And then the last one here, causal, has a number of different designs. You could have a randomized design. When it's randomized, that means the people in the study get to be in the different groups by random chance. It's not by, some person decided to have this group here and then this other group here. That's not random. They're assigned to group randomly. You can have a blinded randomized control trial. This is where the people who are in the group don't know if they're in the experimental group or not. It might be placebo that they're getting. So we would call that a placebo-controlled, randomized, blinded trial. If they are double-blinded, what that means is not only are the people in the groups blinded, in other words, I don't know if I'm getting the actual treatment or the placebo treatment, but the people who are analyzing the data are also blinded. And so you're collecting data and you don't know which group the person's in. You're analyzing data, you don't know which group the person is in. And so let's say you have a double-blinded randomized controlled trial and you're looking at giving people one drug versus another drug, or one drug versus a placebo rather. And so let's say group 1 are randomized to get this drug, group 2 are randomized to get a placebo. Everything looks exactly the same. And so let's say you're the one handing out the medications, you're the nurse in the study. And so you hand group 1 and group 2 medications. You don't know which people are in which group, and you don't know what pills are actually the drug and what pills are actually the placebo. You're blinded, and then the people taking the pills are blinded, so it's double blinded. And then ideally, the people who analyze it don't know which group is which until the very end. At the very end, then you open up the envelopes or whatever it is, and you're like, oh, look, this was group 2. Group 2 got the drug. Who knew? And then you can look at your data and interpret it because you've already done the analyses. That means that you didn't have any bias that got in the way of getting your results. That's why we do blinding. Okay, controlled, like we had said before, controlled means that you are controlling all the other variables, like what the drug looks like, who gives you the drug, what time of day you take the drug, etc. All those things are the same in both groups. And so because one group doesn't get the drug, it's sort of like saying they're the control for the group who does get the drug. Everything is the same between those groups except for getting the drug. So that's the manipulated variable. Manipulated variable is getting the drug. And that way you have a randomized, double-blinded, controlled trial of this drug versus a placebo. So that is a great example of an experimental design, a study that could be causal if you could control all of the things. And so we try to be causal. We try to do the best we can. And then we have the best we can do. That's what it is. A quasi-experimental design is where you can't randomize people to group. A lot of the reasons why you can't randomize them to group are because these are things that you can't control in people, or that it's totally unethical to control in people. One example is smoking. Let's say you wanted to look at the effect of smoking on kidney cancer. you can't get a group and then randomize them to either smoke or not to smoke, because it's not ethical to tell someone they have to smoke to be in your group. Because what you're doing then is you're creating a health problem for them, because we know smoking is wrong for your body. It is not healthy. So a quasi-experimental, let me say that again, a quasi-experimental does, wow. Okay, I know you know what I mean. One of those is quasi-experimental is what that kind of a design is. When you can't randomize something for either ethical reasons or because it's just not practical or impossible to do. When you can't randomize a group, then you have a quasi-experimental design. So you can't ever say you've done enough to say you have a causal experiment, but you can approach it. You can be close to it. Quasi means getting close to it, okay? So those are three big examples: frequency, association, causality, with some smaller, more specific examples of studies in each category. Then we come to the last two things on the slide, which are a review article and a meta-analysis. So we're not going to look much at these in this class, but you need to know they exist. A review article is essentially an article where the person looked at all of the literature and just kind of wrote a big summary. And so instead of reading like 50 articles and trying to figure out what the literature in general says about something, this person does the work for you. And so if you trust that the person did a good, thorough job, then you just go read their article and they do a review of all the other things. So that's a review article. A meta-analysis article is a little bit similar to a review, but instead of summarizing what the articles say, what it does is it actually takes the data that's reported in each article and combines all that data together. There are specific ways of combining data so that statistically it makes sense. There are rules and ways you do it beyond this class, but a meta-analysis then is a way of combining all of those data from a whole bunch of different studies and then basically summarizing the data. So instead of summarizing what the article is saying, you're summarizing what all of the data said when combined. So that's a meta-analysis. Sometimes those are extremely useful in figuring out what everybody says. The problem with them are problems would be that some meta-analyses are looking at data that is too different to be compared, and that some people do experiments that are more well-controlled than others. They might use different variables, they might use different measures, etc. And so sometimes it's kind of hard to make all of the data combined in a way that makes sense. Sometimes you're looking a little bit too much at apples and oranges. So that's the caution with a meta-analysis. So now for you, what you're going to learn how to do is identify the right design for your question. And so keeping in mind, what we're doing is creating a research proposal. So during the whole class, you're going to create this research proposal. Today is the first day that you're going to take a stab at beginning it. And so your assignment for today is to identify some questions and some designs. And so that's what all of this here is leading up to, is you being able to choose a question and figuring out what design would make the most sense for that question. So today you will choose 3 just for fun. They don't have to be 3 that your hearts are set on. They just have to be 3 that you can say, here's a question and this is a design. I just want to check your learning here. So we're going to keep it simple for this class. If you want to find out about something like how many people like chocolate ice cream, well, that's a frequency study. If you want to find if 2 things are connected somehow, that's an association study. And if you want to find out if one thing makes another thing happen, that is a causal study. So I think you guys probably have all that pretty well in hand at this point. I think I've repeated it enough, right? So you have to come up with a question. So I'm going to give you one more example to help you see how can I come up with a question. Here's an example. Do students who eat more vegetables get better sleep? So you measure the number of vegetables eaten and you measure the quality and quantity of sleep. We'll talk a little bit later on how to measure things and what that means. That's not for today. But for today, the idea is you're finding that question. Is there a relationship between those two? And so what you've got is an association. Is there an association between vegetables and sleep? So in your research proposal, what you would write is, here's what the design is. Design is one of your subheadings. This was an association design that examined the relationship between two variables, amount of vegetables eaten by SVU students and quality of sleep in those students. Okay, hoping that is pretty straightforward and simple at this point. And so how do you start your research proposal? Because gentlemen, it's time to start your engines today, right? Come up with a research question. So this is what you're going to do today. Come up with a research question. You're actually going to practice on 3 questions. Questions come out of your current knowledge. So your current knowledge might be sleep is a thing and you can have quality and quantity. And vegetables are good for you. Maybe there's a relationship. That's you basically from your current amount of knowledge. You can't ask questions about things you know nothing about, right? That's just kind of obvious. So how do you get more knowledge and how do you get more questions? This is where you get to wake up your intellectual curiosity. Now, I understand it may have been beaten to death when you were in high school. And you may have been trained to only regurgitate information and not ever think for yourself. So it's time to set that aside. You know, like you thought as a child, you were a child, now you're an adult. Now you're in university and you get to set aside childish things like only regurgitating information and saying, well, is that going to be on the test? You're right, because that's just regurgitating information and performance, and it has nothing to do with intellectual curiosity and actual learning, which is what we're going for here. You want this to be fun, so you've got to cross the line into learning and intellectual curiosity. Otherwise, there's no way this will ever be fun for you. It will just be stressful. So how do you get more knowledge? You read the literature, you go look up articles, look at research papers. That's how you're going to create your research proposal. And so you come up with a question. Your question has to be answerable with the scientific method. Like, what is the meaning of life? I can't answer that question with the scientific method, so you can't use that question. It has to be answerable with the scientific method. So you have to be able to somehow make an observation of a behavior that will answer that question. You can use descriptive questions. You can use causal questions. What are you interested in? What knowledge do you already have? You know, just come up with a number of questions. So practice that. Here are some more examples. Hopefully this will spark ideas for you. Do people who wear masks get different or fewer illnesses than people who don't wear masks? Does childhood trauma result in a smaller hippocampus, which is part of your brain, in case you didn't know? Do male clients like female therapists better or worse than female clients like male therapists? Do white cars hold their resale value more than other colors? Does the herb rhodiola rosea help reduce depression as compared to a placebo? Does peer pressure make people more likely to lie? There are all kinds of questions that you can ask. As long as they are able to be answered with the empirical method, then you can use those. So don't make this question your super interesting, important question. Like your life's work is probably not going to work very well for you in this class because it's 6 weeks long, right? And so trying to do your life work in your research proposal will only lead to frustration. I promise you, just come up with something simple and easy. The idea here is to learn how to do a research proposal. It's not how to write the research proposal for your life, okay? The point of the project is to learn it, not to establish dominance in the field. So doable question, keep it simple. The same advice totally applies to other projects you do for school. It applies to your future thesis or dissertation if you end up doing that. These are places where you learn how to do something, not where you do your life work. You do your life work after you're done with your dissertation. So that same advice will apply, and you're welcome, right? Because that will save you much pain and anguish. If you want to compare one condition with another condition, that's a randomized controlled trial. So as you're coming up with your questions and you're thinking about what is the design going to look like, here's your help. And you can come back and look at these slides, or you can take a screenshot of this if this helps you with the homework. You might want to see how one variable changes in relation to another. That's correlation or association. I'm hoping the repetition is really working for you here. If you want to just measure a variable, that's a frequency or descriptive. So think about your question, think about your 3 questions, and identify which designs make the most sense for those. And then I'll see you next Tuesday, and we will discuss chapter 2. Have a great weekend, and I will look forward to talking to you again.